So we saw that in a number, here we have the base and we have the power. This number should be written this way. As much as the power is, we multiply the number by itself. And we saw that any number power to 0 is equal to 1. Any number power 1 is equal to itself. Any number power 2 is multiplied by itself. Any number power 3 is multiplied by itself 3 times. And so any number power n is multiplied actually by itself n times. And we saw this, we calculated it. We calculated this one too. Here we wrote these in form of prime numbers. We solve these. This should be known by heart, the first 3 at least. And then we saw that minus times minus is equal to plus. So the answer is positive. And we saw that when we have an odd power like 1 or 3 or 5, the answer is negative. When we have an even power like 2, the answer is positive. Minus 1 power 2 is equal to 1. Minus 1 power 3 is equal to minus 1. Minus 1 power 4 is equal to 1. And it goes on like this. The same thing for minus 2 power 1, the answer is minus 2. Minus 2 power 2, it's 4, so it's positive. Minus 2 power 3 is negative. Minus 2 power 4 is positive. So when the number has an odd power, it's negative. When the number has an even power, it's positive. And we saw the difference between these two. When we have a bracket here, the answer is 16. When we don't have a bracket, the answer is minus 16. But here, for the power 3, it's the same answer because a number power 3 has the negative sign. So here we have negative, minus, and here we have minus in the answer. So it's the same answer. Try to find these numbers using a calculator. Where's my calculator? I'll try to do it too.
I think it's too much, but I'm not sure.
Yes, it's right. It starts with 4.
43.
Yes, sure, it will be a big number because it's power 8. So logically, it will be a big number. The second one, minus 2 power 5. Don't forget the bracket.
Minus 32. No, not minus. It's 32.
It's minus 32.
Oh.
The power is 5. 5 is an odd number, so the answer will be minus.
Yeah.
Minus 7 power 3.
Minus 343.
Minus 3 power minus 3. Your answer is 1. It's 1 over 27, right?
Yeah.
Minus 1 over 27. It's a fraction. Press on SD and it will give you the decimal form,
Oh yeah.
which is minus 0.03, etc. Did you get it?
Yeah.
Okay, so the SD button switches from fraction to decimal. In case you need a fraction, you can get it. In case you need a decimal, you can get it. Now let's start with the formulas of powers. You don't have to write anything now. I will give you, after we finish them, I will give you all the formulas together so that you can write them.
Okay.
The first formula is this one. A power m times a power n is equal to a power m plus n. So if we're multiplying the same number, it's the same base, a, but different power. Here power m, here power n. We add the powers. For example, 3 power 1 times 3 power 4. What is it equal to?
It's equal to 3 3 power 1 plus 4.
It's equal to 3 power 1 plus 4. Okay, equal to 1 plus 4 is
5.
5. So it's 3 power 5. This is the first definition. If we're multiplying the same number, different powers, we add the powers. And it's equal to 243. Now, if we're, what's this? It's the same. Other examples here, you can see 2 power 6 times 2 power 4 is 2 power 6 plus 4 equals to 2 power 10. 11 power 2 times 11 power 5 is equal to 11 power 2 plus 5. We add the powers and it's 11 power 7. Now, if we have AB power M, AB means A times B. We don't have to write the times, but if we have AB, it means A times B. If it's power M, it means it's equal to A power M times B power M. For example, if you have 2 times 4 in the bracket power 3, it's equal to 2 power 3 times 4 power 3. So you give the power to each of them, 2 power 3 and 4 power 3. Is it clear? Is this one clear? When we have two numbers multiplied and they have the power, we give the power to each of them and we multiply them. Okay, don't confuse between the first one, which is when we add powers. Here we add powers because it's the same number and different powers. Here it's not the same number. Here it's A, B, two different numbers with the same power. Two different numbers with the same power, in this case power 3. So we give the same power to both numbers. Here, if we have, it's the same formula actually that you saw now, but in a different manner. Instead of here, this one was here, and here it's on the other side. So consider it another formula. Just focus on it now. A power n times b power n is equal to a times b power n. For example, 1 power 2 times 3 power 2 is equal to 1 times 3 power 2. Okay, 1 times 3 is 3, power 2 equal 9. Now with fractions, if a fraction has a power, the whole fraction a over b is to the power n, it means it's equal to a to the power n over b to the power n. We give the power n to each of the numerator and the denominator. For example, 3 over 5 power 2 is equal to 3 power 2 over 5 power 2. We gave the power 2 to each one of them. 3 power 2 over 5 power 2. This is it. So when you have a fraction that has a power, you give that power to the numerator and to the denominator. And when you have a negative power, for example, a power minus n it's actually equal to a over n. A few minutes ago, you obtained on the calculator 1 over 27. So if you put on the calculator 27 power minus 1, try to put it, 27 power minus 1, what do you obtain? What?
I can't find. Oh, okay. 0.3, 0.03.
In fraction.
Oh. Because I'm using the calculator, this one.
Oh, the phone calculator?
Because I can't find my other calculator.
You were using this one yesterday?
Yeah.
This is not it. This is a phone calculator. We need a scientific calculator. So I will do it. When I put this 27 power minus 1, I obtain 1 over 27 on the calculator. So if we give a number power minus 1, it's like we're inverting it. This is the idea. So for example, 4 power minus 2 is equal to 1 over 4 power 2. And this is also important, yani you should know it. And if you have the same base but different powers in a fraction, a over n over a over m, it's equal to a power n minus m. A power n over a power m is equal to a power n minus m. The power of the numerator minus the power of the denominator. Let's take an example on this. 2 power 5 over 2 power 3 equals 2 power 5 minus 3. 5 minus 3. We subtract the powers. 5 minus 3. And that's equal to 2 power 2. So these are all the formulas that you should know on. We saw them now one by one, and we gave examples for each one of them. You should write them now on a paper or on your copybook that you're using. I don't know if you're using a specific copybook for these sessions, or it doesn't matter. So we have the same number and different powers. What do we do? You can check your formulas.
We have to do 3 power 2 minus 3.
2 plus 3. We said that if we have a power n times a power n, it's a power n plus m.
Yeah.
So it's plus. We add the powers. If we have a multiplication here in this way, we add the powers. So it's equal to 3 power.
3 power 5.
Yes. That's it. You should know the difference. This is the first example. Another example, 3 power 6 over 3 power 2 equals?
It's equal to 3 power 6 minus 2.
Yes, in this case, because it's a fraction, we do minus. And it's 3 power 4. 6 power 0.
It's 6.
No, it's 1. Any number power 0, it's 1.
Yes.
6 power 1 is 6. 6 power 0 is 1. So basically, these are the examples that let's do this one too. It's important. Where's my pen? I lost it. Oh, here. Okay. 2 power 3 power 4 is equal to, I have 2 power 3 in the bracket and 4 outside the bracket.
It's 2 times n plus 3 plus 4.
3 times 4. I told you to pay attention to this because in this case we don't do plus, we do times if the power is outside. So it's 2 power 3 times 4.
That's what I said.
It's not like this one. The first one we add, but because it's separated numbers. Here it's the same number. We're putting a number to the power 4. So it's like we're multiplying the power of the number by 4. And what's the answer?
It's 12.
2 power 12. Now let's do with 3a. 3a power 2 is equal to
Um. Oh. 3 power 2 times a power 2.
yes. 3 power 2 is 9. So the answer is 9a2. 9 times a2 means 9a2.
Okay. Okay.
2a3 b 4. 2a3b in bracket power 4.
Um. It's 2 power 4
Yes,
times a power 3 plus 4. No, times 4.
times 4 and times b power 4.
B
Okay, so now you calculate each term alone. 2 power 4 is
Um. 16.
okay, 16. A power 3 times 4,
Um. 12. A 12.
12
A 12.
and 12. So it's 16a12 b4. This is the final answer. Do you have siblings?
Yeah, I have a sister.
Older than you or younger?
Younger.
Younger than you. Okay, she's oh, okay. Like a grade 4 or 5, something like that.
Oh, she's in grade
Which grade?
uh grade 5, I
Oh,
think.
5. Okay.
She's gonna be in grade 5 next year.
Oh, okay. Let's move to exponential equations. When we have a number a power x, okay, any power x, if the number a power x is equal to a power k, it means, implies, do you know this symbol, implies?
Yeah.
Implies x equals k. If the a power x equals a power k, it means x equals k. The powers are equal. This is the meaning of it. Let's do this first one. 3 power x equals 27. It means 3 power x equals 3 power 3. 27 is 3 power 3. So it means x equals 3. This x, the power, is equal to the power here, 3. And this is another example. So now try to do this one here, 4 power x equals 1 over 2. First, you can replace 4 by 2 power 2 power 2. Okay, replace 4 by 2 power 2. So you will have 2 power 2 in bracket power x.
Wait, wait, what? It's 2 power 2.
2 power 2 power x.
Hmm.
And we continue. 2 power x is 2 power 2x. Right? And 1 over 2 is 2 power minus 1. We said this property, if a number is 1 over something, it's the number power minus 1. So we're using this property here. 1 over 2 is 2 power minus 1. So now what do? We said that if a power x equals a power k, it means x equals k. Here we have 2 power 2x equals 2 power minus 1. It means 2x equals 2x equals minus 1. The powers, this power and this power, are equal. We divide both sides by, this is 2x, we want it to be x. So we divided by 2. 2x divided by 2 is x, and minus 1 divided by 2 is minus 1 over 2. Solve for x. 2 power x equals 2. What's happening?
My sister came in the room.
2 power x equals 2.
It means x is 1.
Yes, because 2 is 2 power 1, so the powers are equal.
It's equal to
X equals 2. And this way we do examples. This one,
it's 3.
27 is 3 power 3, so 3 power x is equal to 3 power 3. X equals 3. This
um, 0. It's 2 power 0.
yes, 1 is 2 power 0, so x equals 0. So you see, you're getting better. You're becoming good with powers and all this. Another exercise here. It's the same question. Solve for x. 4 power x equals 32.
It's power 4.
If you see, okay, here there's something you should do. Either you write 32 in form of a power of 4, which is not possible actually. You can't write 32 in form of power 4. You can write it in form of power 2.
Oh.
So
16. Oh, oops.
We have 4 power x. Yes, 4 power x equals 32. Sorry for my writing. I'm writing on the screen. 4 power x equals 32. You can replace 4 by 2 power 2. Okay? So 2 power 2 power x. And 32 is 2 power.
I don't know.
It's 2 power 5 actually. 2 power 5. 2 times 2 is 4. Times 2, 8. Times 2, 16. Times 2, 32. So it's 2 power 5. So here you have implies 2 power 2 power x is 2 power 2x. You just remove the bracket. You can it means it 2 power 2 times x, okay? 2 times x is 2x. So 2 power 2x equals 2 power 5. And this gives us the powers which are equal. 2x equals 5. And you divide by 2 on both sides. You obtain x equals 2 over 5.